All right, so this is a water damaged iPhone 6 with prior repair attempt.
6S.
6S. This is a water damaged 6S with a prior repair attempt. So let's talk about how we would start. So let's all start together with just a visual microscope exam. So we're gonna look here, and let's see what you guys think. We're gonna look for any kinds of signs of water or corrosion that are on this board. So let's look around and you guys tell me what you think here. All right, let's flip over. I don't see any signs of water around here. This is sort of a hot spot typically. No water. I'm looking for this kind of, oxidation possibly there, but very minor, if any.
This wasn't submerging either. This was rain, basically. Water.
Okay. All right, and then somebody's been here. All right, so what we're learning now is that. All right, so these caps here were missing.
Yes.
These two here, 1, 2. Oh, 1,
Yes.
2. So those were missing. All right. So let's think about that, because we want to. This is a story, and we want to understand the thinking that went into this board before it got here, because that is a variable and that's part of our repair process. So now now we've kind of gotten to a point where we need to ask, why would someone have taken off all of these caps around here? So in my judgment, just from looking at this board, I think the likelihood that any of these caps needed to be replaced. You said you saw pictures of them?
I have them. I can show you.
All right, let's look at that. That would be important.
The photos
Okay.
of the damage.
All right, so while that's coming up, let's think about what do these caps do. So these two caps here are on a line that if we looked up in the schematic by looking at the board view and saying, oh, that guy's name is C2020, and today's schematic, tell me about C2020, it would tell us the name of a circuit that C2020 is on, and it would
CPU, or GPU.
And it would say PP underscore GPU. PP underscore GPU. Now let's try to guess. What do you think? What kind of a thing is that? PP, power of the GPU. Sounds pretty important. Power of the GPU. Okay. So if we were to, then we would have to say, well, okay, power to the GPU. Why would someone take a capacitor off that line? What problem do you think they'd be trying to solve?
They think it's shorted.
They think it's shorted. Yes, exactly. So capacitors, if we looked at a schematic, we could see that they all have one foot on a line and the other foot on ground in general on an iPhone. So a capacitor then, a normal capacitor is on a circuit and it has one foot on ground, and then it has an insulation space, and then it has another foot that is on whatever circuit on the line. And if you were to get out your electron microscope and see how these little ceramic capacitors are built, you would see that they are the side that's on the line, the side that's on ground, have little metal plates that come very close together, but they don't touch. So there's an insulation space between them. So you tell me, how do you think they fail?
Touch.
They touch. So therefore, the capacitor becomes a wire. It becomes a wire. Yes, exactly. So a capacitor can fail by becoming a wire. Now, once that wire is created, now what happens to the line? It's always connected to ground. Exactly. So then it's always connected to ground. So what happens to the voltage that's in that line? And so therefore, if you use a multimeter to say, what voltage do I have here? What would it say?
0.
It's always going to say 0, regardless of what it's supposed to be. Now, do you think that a voltage is important for a line called PP underscore GPU? Yes, we'll put that in the category of, if that's actually a problem, we need to solve it. So we would be very interested in whether or not that line was actually short or not. So let's think about this. This trips up all kinds of people all over the time. This is number one misconception in board repair. And that is on most of the lines in the iPad, in the iPhone or in the iPad, we would be able to kind of come up with a relative measure of the overall resistance of the line to ground. Resistance to ground. Now, if something is a wire to ground, resistance is high or low? Low, exactly. It'd be like 0. Resistance to ground would be 0 if a line was a wire to ground, meaning a short to ground. It had a short circuit path to ground. So on a normal line, what would we expect if we were to just measure straight up resistance to ground? What kind of number would we expect? I don't know, 100 kilo ohms or, 500, we don't know, something like that, but some kind of a big number, right? Now, and that's true for most lines that are going to carry a voltage and they're going to send current and they're going to have some sort of resistance to ground. However, there is a caveat. So let's think about the good old Ohm's law stuff. So let's think about voltage and let's think about current and let's think about resistance. All right, so let's get in our mind an idea of what voltage is. So what is voltage? We're going to have to come up with some kind of analogy. Pressure, I like it, a push, a pressure. So voltage, let's think of as a push, a pressure. Like right now at your house, back at home, you probably have the sink is turned off in your kitchen. If you were to take some kind of a device and measure the water pressure back behind your sink, would there be water pressure in the pipe behind your sink?
Yes.
Water pressure is present. Now what about current, flow? Do you have any flow right now?
No.
Hopefully not. Right. So pressure, voltage is just that push, but it's not going to do anything. It's not going to actually move electrons unless you have a path. And so when you turn on your faucet on your sink, you're creating a path. The pressure pushes electrons and you get current. So current is miles per hour of flow. Electrons actually moving through a wire. All right, now let's think about in a line like the main artery of the phone, the voltage, the typical voltage, is about the battery voltage. And who knows what is a battery voltage for an iPhone? 3.8, something 3.8, 4.2, something in that range. So 3.8 is the push, and then you're going to get a certain amount of current, miles per hour, that you could measure. And you could measure that, and it would be, somewhere in the, milliamp kind of range, right? Except for this very, very special lines that power CPUs and GPUs. So if you look on the schematic, the actual miles per hour in one of these CPU or GPU power lines is very high. The actual current is very, very high. So what do you think the voltage is going to be on those lines, high or low?
Very lower.
Well, if you were going to ask me, I see a lot of cars driving down the highway, so what's the push? Well, it's going to be a big push because they're moving real fast. That's what I'd think, right? But that's not how it is. So the actual voltage on these GPU, CPU power lines is, guess what?
0.
It's less than 1 volt,
Right.
like 0.8.
Yeah.
So that push is it's a tiny little, go on guys, just put on there. And yet the current is a massive, powerful highway tractor trailer buzzing down that road. So how would that be possible then? How could such a lead to
Low resistance.
low resistance? Yeah. It's really only going to happen if the wire then is really like butter, right? It's going to have to be ice so that a tiny little push is going to, make current fly. So just from knowing that, then let's make a prediction. Just on a normal phone, normal GPU power line, what do you think I'll get if I measure resistance to ground of that line, high or low?
Low.
I'm going to get low, right? I'm going to get low. In fact, I might get something that's so low, it almost looks like 0 because it's super low. It's just naturally really, really low. And so that is how we get to the common newbie mistake, because what do people think when they measure low resistance? They think, short to ground. I found a short to ground. It's low resistance to ground. It's a short to ground. That's a problem. I better fix it. And especially if you combine that with the physical appearance of that cap with green, what are you going to do then? You're going to think, I have a short to ground on PP_GPU, and I think it's probably this cap, so I'm going to take it off. So what we had missing then were 1, 2, which are on PP GPU, and then we are missing these two and these two. So here, these two, A and B. If we look up and say, what are those rails? It says here, one of them is called PP GPU. And the other one, I can't tell. It has a 1 with a 0, like a
Yeah, well, here are the rails. What's the number?
C4000.
Oh, well,
Is this a cell phone right here? Or is that actually a joint? Just a weird light. Never mind, it's a joint.
probably a giant.
Mm-hmm. Yeah, it's a joint.
It's the light.
4,000.
Doesn't matter.
Don't remember what he was.
Okay. So now we have one of the other things that was missing couldn't have possibly been the problem. All right, but these guys here, these guys are on a different line. All right, so these guys are on a different line, and the name of the line is called PP VCC main. All right, what do you guys think PP VCC main is? Sounds like PP positive power VCC. Okay, this sounds like main artery, main power rail, and experience tells you that that's certainly the case. So this is the aorta. All right, so how important is the aorta? Definitely important. So now, if we actually have a short to ground on the VCC main, the main power rail, then that's a definite problem. That's going to be why the thing's not going to turn on. You can't have zero resistance to ground on the aorta. You can't have a hole in your aorta when it's trying to pump blood. It's just going to sit there and bleed out. That's a big problem. And so if that was the case, that we actually had a short on that power line, then we would definitely want to find out why and see if we could find, is anybody a wire that we can just clear? So that does make sense. And so these two guys were then missing, presumably because someone measured and knew that they were trying to solve that problem and not just randomly because of physical damage. But now we don't really know. But let's assume that they did have a VCC main short and that by removing those caps, that actually solved that problem. So in that case, then you might get the phone to turn back on. So now we've got a little bit of a picture of why what was done. And then when we get back down here, this guy is on a completely different rail as well. So it's again, unclear. That's on a NAND power rail. Needs to be there, but just kind of taking that guy off, unless there's a short, it doesn't really make a lot of sense. All right, so that's where we are now. Okay, physical exam is over. Findings are a lot of prior repair attempt, not a lot of corrosion, and we don't really know what the current status of this board is at all as far as is it going to power on. So what should we do next?
Have to check if it's like backlight problem, image problem, or
Yeah, so we start with rule number 1. What is rule number 1? Rule number 1, and this is something I made up kind of recently, and I really like it. Rule number 1 is you don't have a board problem until you know you don't have a parts problem. You don't have a board problem until you know you don't have a parts problem. Maybe you have a parts problem. Maybe this board's fine. We don't know. Right. So rule number 1. So we're not going to do a goddamn thing to this board until we rule out rule number 1. All right. So that means we need some known good parts. All right. Do we have a DC power supply?
I can find you one.
Great. All right. Now this is going to be hard. We need to prompt to boot and we need to be able to see this. Here's what we want to know. How am I gonna make this DC power hook up to simulate the battery? What am I gonna do?
Let's see where is the positive side.
All right, I got a vote to say where is the positive side. Now, how do I use my multimeter to figure that out?
Look on this tonight. One on ground.
Screw that.
One
Alright.
on ground, one. Which one's positive, which one's negative?
Okay, that sounds like a great idea. What about continuity mode? What does that do?
The one the ground is gonna be.
Come on, mofo. That looks like continuity mode. All right, there we go. All right, so beep means I'm a wire. So let's ask the question. Your ground Which one of you sides of the battery connector is a wire to ground? Are you a wire to ground? Yes. Are you a wire to ground? No. So what side of the battery is this gold thing here? That's ground. And therefore, what's that?
Positive.
Right. So, what happens if I do this? This is the DC power supply. Can I just do that? And I see, so far, no current consumed. But is that normal or not?
Yeah.
Yeah, that's actually good, though, because if your phone is off in your pocket, do you want current moving and draining the battery? No. Okay. Now, how am I going to prompt it to boot?
Do you have a tweezer?
I'm going to,
Well, if you're
with
Jessa,
my
you can
pinky
use tweezers.
finger. No, I can't do that, man. Look at me. I don't have that many hands.
Ask you for that.
Right, now I'm going to I'm going to try to hit the power button. Alright, so now the rest of us, we need to have our eyeballs on the DC power supply, which is going to be too hard for us to turn around. Alright, right now DC power supply says, yes, I'm putting 3.9 volts into this device, and the current is 0. So I'm going to hit, I've got the power button connected. Now I'm going to hit power, 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 power button, and let go. And it goes to 0. It goes to 0.05, so 50 milliamps, and then it just kind of hangs out there. All right, let go. Let's try again. So just lift one off. All right, stick it back on. So you guys can come look, read the DC power with us. Maybe we're fucking it up. All right, let's hit prompt, 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 prompt. Let go, and it stays again at 0.05, so 50 milliamps. Right. My next question would be, well, I'd like to see whether or not I get the same or different behavior by prompting it to boot the other way. What's the other way I can prompt the phone to boot? Plugging it into USB, yes. So who had the USB power bank? Great. All right, back to work.
Back to work.
Mm-hmm. Do you remember which one's ground? Ready? Okay. So we're at 0. That's good. So we're going to just prompt to boot with USB. Prompt, 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 and pull it out. And it doesn't seem to respond. Prompt, 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 prompt. Pull it out. All right, let's look at the connector and see if that's... So when a DC power supply does nothing like that, that generally means that there's some kind of a... Like, is that thing on?
No. It's
All right.
Yeah, it's on now.
All right, prompt, prompt, prompt. I still don't see the flicker. Okay.
No.
Okay, so when we turn the USB power bank on and prompt it to boot, it goes to the same 50 milliamps. So both ways, it does the same findings. What does that mean? So what category of a problem is that? Here's your choices. Actually, where's my phone? Well, I just wanted to show you guys. All right, let's pass that over so that you guys can see what normal looks like. All right, here. Can you hook me up? All right. Don't fuck up my phone. Ready? Prompt, prompt, prompt. And I see an Apple logo, and you guys can come around and look, see how the DC power supply is. And you can see what it does. Ready? Here we go. Power button, prompt, prompt, prompt. Watch what it does. It's 240 milliamps. We'll assume that it would have done work. Here we go. It's hard to have this on there. All right, give up. So the normal phone is going to consume a EKG of current, and this one would likely do that. So what can we learn here? So what kind of a problem do we have then overall Does it sound like there's a short circuit and we have rampant current running to ground, or does it sound like we have, you know, an open circuit? Or is this phone kind of a brain dead phone?
Negative.
Right now it's a brain dead phone. It is not able to tell. It's not able to like issue any instructions. So it would be kind of like the school principal and the PA system. Instead of saying, everyone please stand up, we're going to say the pledge, and today we're having chicken nuggets with the chocolate milk. Instead it's just, and nobody knows it. Nothing happens because there's no instructions that can be had.